Oh, hey everyone. So we're going to be talking about modeling equations with variables on both sides. And more specifically, we're going to be looking, of course, at the integers right here. So I'm just going to change my pen to red here. Uh, with integers, we have to understand that negative 3c in this case and negative 8 or subtract 8 are the integers in this equation. So there's a number of methods we can do to solve this. And I'll be showing you one method and a couple of examples, and you're going to have to determine this. So I'm just going to rewrite this equation. So this is minus 3c plus 7 equals 2c minus 8. Now, of course, we have to get the variables on each side and the constant terms on one side as well. So the simplest thing to do here is to, oh, excuse me, is let's worry about dealing with the numerical coefficients and the variables first. So if I have minus 3c on this side and I need to move this 2c over to here, I do the opposite or the inverse operation. So this is a plus 2c. When I move it over here, it becomes a minus 2c. And then I have plus 7 equals negative 8. Now, I have to move the like terms around just like in the previous one. But again, we're going to be dealing with integers. All right. So I'm going to get rid of the positive 7 over here. So I'm going to subtract 7 from this side. And when it comes over here, it's going to be a negative 7 or subtract 7 over here. I'm just going to carry this down. So minus 3c. And this is subtract 2c, my equal sign. Now this is a negative and I'm adding a negative. So it's 8 plus 7, which is 15. And I take the sign of the largest number, which is 8. And this becomes negative 15. Okay, so I've been dealing with the integers. So I have that to this point. Now I have this equation over here where I can work with the like terms. So the c stays the same. Bring down the negative 15. So this is negative 3. Subtract 2, again with our integers. It's 3 plus 2, which is 5. But then I have the sign of the larger integer, which is the 3, which is this is now becomes negative 5c. Okay. Then what I have to do is I, of course, have to make sure that I zero out each of those things, or in this case, do the inverse operation of multiplication, which is division, because this is negative 5 times c. So in order to do that, I have to divide each side by a negative. So negative 5 divided by negative 5 is a positive 1. So that becomes just the 1c down here. And down here, I have the negative 15 divided by the negative 5. A negative divided by a negative gives me a positive. So this is 3. Okay, so then I can verify that term by rewriting the equation for the verification. So I've done the solve. The second thing is I need to make sure that the left side of the equation is balanced to the right side of the equation. So I have negative 3. Replace the c in the equation with a 3 plus 7 equals 2 multiplied by 3 subtract 8. Order of operations state, we do things in brackets and exponents, then multiplication or division, then addition and subtraction. So in this case, I have the multiplication first. So I have negative 3 times a 3 is negative 9 plus 7. And I have 2 times 3, which is 6, subtract 8. So I would go through here and I would go negative 9 plus 7. So I'm going more towards the right. I'm going towards the right. So negative 9 is negative 2. And 6 take away 8 is negative 2. Both sides of my equation are balanced. Okay. Therefore, C equals 3. And that is correct. So I solved the equation, then I verified, and I've proved that C equals 3. And you'll find out a little bit later why this is important with the verification. All right? Thanks.